Okay, students, so welcome to today's class. Now we're going to start a class, okay? So let us wait for other students to join and then we'll start the class. Let us wait for other students, then we'll start the class, okay? Okay, how's everyone? Respond in the chat box, students, respond in the chat box. I hope you're able to see like my videos, okay? So we'll start the class again soon now. Okay. Nobody have joined yet. What's the issue? Well, let us go on the YouTube then. Not fine with this. Okay. So students, I have started the class. Okay. I mean, everything is fine here and here we go. Okay, let us start it. Yes. So welcome to today's class. I hope I'm audible to you. Okay, properly. I hope I'm audible to all of you. Okay. Yes. So one of the students have joined. Sneha Ghosh, welcome to today's class. How are you? How's everything going on? So today we'll start, few of the topics remaining, then the wave optics is completed. Optical instruments, just in 25 minutes, I can complete in the next class. Okay, just in 25 minutes. And then we'll start the wave optics. That is next Monday. Finish. So you'll be studying a new chapter from maybe new teacher. It may be okay. So let us finish this last two remaining things. Lens and prism. Lens and prism. Okay. Good. Okay. So you're good. That's great. So I'm launching a poll. Please participate in this. Am I audible and is the screen visible to you or not? Am I audible and the screen is visible to you or not? Yes. Okay. Good. Very good. No, no. Maybe I told maybe. I didn't told yes. It may be. Maybe. Okay. Okay. So that's a cool emojis. Okay. See, now please be focused because the less students are here and like we have to start. Okay. So contents, if we see in the yesterday's class, what the things which we have completed? Yesterday, is this Uh, is a screen available here? Hold on, let me. Avanti fellow screen. I think I need to share it again. Oh, my video is pinned by mistake. See, the contents are this. If you see on the screen, okay. The first thing is we have seen in the previous class. We have studied what spherical refraction through spherical lenses. This we have seen in the previous class. Okay, this topic is already completed in this your class, that is Bhopal region class. Fine, completed now. Today we'll start this lenses. After lenses, we'll complete prism. We'll try to complete. Okay, so numericals are provided for both this also and this also. Lenses also, prism also. Okay, so let us start it now. See, let us revise something before starting the class. Okay, so few things I'm revising here are these. You can see. What was the formula for this? You know, this is the formula. We have already seen what it says. It says like this. If the object is here, if the object is here, it is here, object. And the image is here. Suppose you keep an object in front of refracting surface. So image will be formed here. That's fine. And suppose this is the boundary which is separating two mediums, that is mu1, mu2. Mu1 is having the refractive index of the air. Mu2 is having refractive index of the medium. Okay. So if they say you that what is the formula which is connecting both the things, that is object and image, so what you will write? You will write this thing, that is mu2 minus mu1 upon r, radius of curvature, mu2 upon v minus mu1 upon u. Okay, this is the formula, na? We need to remember this formula. Let me tag this formula in a cloud, heavenly cloud. Okay, something like a cloud. We see in animations, no, in cartoons, maybe Tom and Jerry. Okay, this formula we know. Then we have seen the applications, but before applications, we have seen one more thing. What was the thing? We have studied some important points which are related to this formula. Okay, what were the important points? That above formula was valid only for the paraxial ray. Okay, na? This formula was valid only for the paraxial ray. Just hold on, let me see on the YouTube what these students are doing. Okay, everything is going fine. So you have texted something. Yeah, one more student have joined. Who's this? Or you are asking what is paraxial mean? See, if which is one more student who joined? Okay, JNV Demetri students have joined. So welcome to today's class, all of you. Okay. So we are just recalling few things. Then fast we'll start which topic, lens and prism. Let's go with thoda sa, little bit refreshment for all of you. See, if you break this term, para-axial. Axial means what? Axis. Okay, let me ask from Demetri students. What do you mean by paraxial rays? One of the students from the class have asked this question. Paraxial matlab kya hota? So I am asking from you. What do you know about paraxial rays? JNV students. Demetri students. Dantari students. Any one of you? Suppose you're taking a mirror This is concave mirror. See, there are two definitions which are given for this word. This is axis. Para means what? See, something which is very close to the axis. One term is this. Something, the rays which are very close to the axis, or the rays which are making a very small angle, that it is like approximately tends to zero, like parallel to it. Okay, such rays known as paraxial. I mean parallel to axis and near to axis. You'll find in many books you'll find near to axis and parallel. But such rays are known as paraxial. Is it fine, Sneha? Parallel axis, parallel to axis, nearby, making small angle. Many small definitions are there. Combine it, we'll get this figure. Is it fine? I hope you understood, Sneha, this thing. Yeah. Cool. Parallel axis. See, UVR you should put with sign. What does it mean? It means object ka distance, image ka distance, radius of curvature with sign. Mu2 is the medium, first medium. Mu2 is the, mu1 is the first, mu2 is the second. Okay. This example also we have solved in the class. This question was also covered with the sign and conventions. Yeah, one thing I need to recall in this is suppose spherical mirror is given like this to you. This is a spherical mirror given to you. This is a refractive index N1. This is a refractive index N2. Okay. And suppose now it is given like this. This is say N1. This is say N2. Okay, you got it. These are two different refractive indexes of the mediums, no? N1, N2. N1, N2. Okay. Now, if I want to put the radius of curvatures sign in convention, what I will put here? Dekho, it is curved in this side. It's curved like this. It means center of the circle or the sphere. Who's this? I'm talking about this one. Who's this is the part. This curved thing is the part. The center of the circle of a sphere or a sphere. Who's this curved spherical surface is the part of. Uska center kahan hoga? It will be, that center will be in this direction. So wherever there is a center, in that direction only we'll put the radius, no? I mean radius of the sphere or radius of the circle, anything. So I'll put here radius of curvature R. And if you are finding that, if you're going, like if you're calculating this radius of curvature, you're going opposite to the object's direction. You're going opposite to the object's direction. So we'll write here radius of curvature as negative if the object is placed here. Okay? Same thing. This is the axis passing through the center. And suppose the object is here. If you see, iska center kahan hoga? Because it's curved like this. Where will be the center of this? Sure, the center will be in this direction. So radius of curvature also I will count in this direction. Okay. So again, if now, N2 said, yeah, very good. See, if now I'm measuring the radius of curvatures, I mean, if I need to measure the radius of curvature, where I need to go? Standing here, I need to go in this direction because radius of curvature is in this direction towards the center. Okay? So if I go in this direction, if the object is placed here, rays are, see, if you make the random rays, it will be like this. So I'm sure that I am in the direction of the object rays as I'm going to measure this radius of curvature. Okay. So I'll put here radius of curvature sign as positive as per the sign and convention, that is plus R. Finish. So this conclusion is finished. This was a very good conclusion. You must always remember this conclusion. Okay. Now let us move towards the next thing. Yes. This formula also I have seen. I think we have solved the question also based on this. Yes. So what was happening in this formula? I mean, they were saying, suppose surface is moving with some Vs speed. Okay. and the object in front of the surface is also moving with some VO speed. Okay, you were saying yesterday you were absent. No problem. I'm explaining it again. This topic, no, I'll explain this again. Okay, who is the student? Okay, Sneha, I'm explaining this again. Hold on. So listen. Suppose this is a spherical surface, and this is an object. It is moving like this. Okay. If suppose the image of this object is somewhat here, and suppose I assume like this, that the velocity of the image of this object is in this direction. Okay. So if I need to find a formula in which suppose if I'm giving the question velocity of the spherical surface and velocity of the object is given to me, and I'm asked to find the velocity of the image. So what I will write? So it will be write this. First of all, you have to write this formula. Okay. This gives you what? V in this, U in this, and R in this. Okay. So now you need to differentiate this formula. Differentiate this formula with what? T. Differentiate with respect to time here. ठीक है, इसको differentiate करेंगे तो क्या आएगा? See this 1 by v का differentiation. Okay, let me do it. And 2 minus v square dv by dt. This we know because 1 by x ka with respect to x differentiation is how much? Minus 1 by x square. Even if you're applying this formula, no, that is xn ka differentiation with respect to x. Remember it. Okay, always remember this thing. Similarly, you will if you will differentiate the next part, this will give you u square because it's already minus there. So minus 1 minus from this, it will give you plus here. This will be du by dt equals to 0. Okay, from this you get dv by dt is equals to how much? This will be plus n1 by n2 v square by u square du by dt. Okay. Now, if I write the values properly, students, this is what? Velocity of image with respect to surface. Okay. And this is what? Velocity of object with respect to surface. And we have studied in kinematics that when there was the concept of relative velocity, you know this thing, I can write VAV is equals to what? Velocity of A with respect to ground minus velocity of B with respect to ground. Okay. Similarly, we'll write here. Velocity of image with respect to surface will be what? Velocity of image minus velocity of surface, like this. And this will be velocity of object minus velocity of surface. And remaining things you have to add here. So you are having now a formula in which we have having these things. So if you are given the values, you can find the remaining one, which is asked in the question, asked in the question, asked in the question. Okay, got it? So this was a question. See, Sneha, this question will be given to you on the PDF. Okay, so you can solve it by seeing the formula. Okay, fine. This question you will be given on the PDF. You can solve it by seeing this formula. Try it out. If you're not getting the question, you can text me on the WhatsApp, or you can, you know, when we'll be in the next class, so you can ask at that time. Okay, let us proceed for the next topics. So these all things I have completed. Transverse magnification is also as a PDF you have to write. I'll give you on this PDF. You can note it down, and both the questions you can check it out. Okay. So now let us start the new topic, lens. Write the heading, students, lens. Okay, Sneha, it's good, excellent. You must always. It must not be like spoon feeding. Okay, so we have to work ourselves also. But there's a lot of positive point for working on ourselves. Like if you're not asking from the teachers and if you're striving hard yourself for the theory, you'll get it, and then you will gain more confidence because you have earned that. You know, you have worked on that. You got it. Okay, it's a good thing. Very good. So rest of the students have joined. Surya Dipti have joined. Excellent. Barsha have joined. Okay, so Surya Dipti and Barsha, all the students are back. Joining with them. Demetri students are always regular. Excellent. Okay. So seriousness always pays. Maybe late. Okay. So the thing is this: refraction through thin lenses. This is what refraction. Write the heading in your notes. Now we'll study refraction through thin lenses because now it's the time for the fresh topic. Recall is done now. Okay. So first of all, write a very good definition on it. See, notes must be proper. Make a good notes. Lens is what? Yes. First order lens convection. Okay, let me tell you how to make these lenses. Okay, somewhat hold on. See, suppose we know this thing. When we are having reflecting surface, maybe like this. If the object is here, image will be here. Why? Because the rays are going somewhere like this. They get deviated. If this is N2 and N1 and N2 is say greater than N1. So this is just a two-ray picture. Here I will get the image on say the axis. I don't know the formula I have used is what? The formula will be like this: N2 minus N1 upon radius of curvature, N2 upon V minus N1 upon U. Okay, this was what? Radius of curvature formula. Fine. One more curved thing I was having this. Object image. Again, for this also, if I call, suppose it's also medium. Okay, so the rays will be going from this, the normal will be here. So it may go somewhere, like appear to diverge. It may also happen, it may appear to diverge. Okay, the picture will be somewhat different. See, let us make the ray. Suppose this is normal will be where? Normal will be passing through the center. So this is the normal. So it is making an angle. If you see, this is a normal, that's fine. On the other side, this is what? The surface here. So if we see the reflection, how it was occurring, I angle, if this medium is denser, it will bend towards the normal R angle. Okay. So now this is making an angle I with the normal here. Okay. If this N2 medium is greater than N1, is the voice not clear? I hope voice is clear now. Dimitri students, I hope the voice is clear. Voice ठीक है? Can you text me back once again? Once again, can you text back? Voice is fine. Okay, Sneha says voice proper hai. Okay, cool. Okay, so we have checked this thing. Now focus here that this was incidence angle. Okay, and this was a scene. Now if again the ray is entering like this, so when it will pass how? When the ray is entering like this, when it will pass, how it will pass? Since it's a denser medium, it will. Since it's a denser medium, what will say? It will bend towards the normal. Bend towards the normal. Okay. So if it's entering like this, it will bend somewhere like this. So I will say the picture will be very different in this case. We'll get the images like this. यहाँ पे अगर हम देखें, if I draw the normal here, it will be normal. If the ray is going along the normal, it will retrace. Okay. So somehow, okay, let us consider the ray diagram. Somehow we'll get the images, whether in this kind of curve or this kind of curve. Okay. In both of the cases, you use this formula. Maybe I have drawn here somewhat error in the ray diagrams. If you see, normal is पे ऐसे होगा. If the ray is coming parallel, then it will go like this. Okay, so I have to change something. Suppose the rays are coming parallel. Normal will be here. So we can say now I and R. Okay, so the picture can be now. It's now it will be cleared here. So this is the formula for this. This was the formula for this. Okay, both the formulas are cleared. Finish? Cleared. Okay, it's finished. So now what's the next thing? What do we need to do now? Okay. See, These are two reflecting surfaces. Now, if I'm combining this kind of curved surface with its photocopy, so let me copy it in copy machine. So this is a copy machine, I've copied it. So I got two things, two same, original one and the new copied one. So if I'm combining this, how I can combine? I will combine like this only. So it will give you a crescent moon. It will give you a crescent moon. Somewhat like this moon. Or if you eat it like idli, like 2, 3, 4 times, if you eat the idli, the remaining figure will be like this. This is the remaining picture, no? Or it's a moon picture, you can say, na? So this is also a lens, and you will get to know like what this lens is, which type of lens is this. See, JNV Dimitri students, don't mute. See, I think the voice is perfectly clear. What's the issue? Okay, let me tell you one thing. So you are combinedly using, okay, can you switch on your video, JNV Dimitri students? Let me tell you where you are wrong. Voice problem hai, let me see. Can you on your video? See, do one thing. Isme what you need to do is this. Ki Avanti fellows pay videos coming, okay, and then there the sound is coming for, okay, let text all the students. I'm launching a poll one more time because new students have joined. Okay, new students have joined. I'm launching the poll one more time. Or you can text in the chat box. Students, you can text in the chat box. Is my voice clear? Is my voice clear? I want you to all the text in the chat box. Shushri, Suradipti, Suhani, all the students, Subhashri, Sneha, Shuchi Mista, and like Mana Mista, and all the students. Please text in the chat box. Am I audible? So I'll be sure that yes, it's not my issue. It's not on my part, like on my side. It's from your technical issue is on JNV Dimitri's side. Okay, it's not my side. Please everyone text. Am I audible? Everything is clear properly. Proper voice is there. कोई issue नहीं है. Background noise ज़्यादा नहीं है. Everything is fine. Sneha says yes. Shushri says yes. Voice आ रहा है. Please, all of you must text. Rest of the remaining students text. Suryadipti, you also text. At least I must know. Let us confirm. Okay. Sneha, you have texted. Please text in the chat box. I'm audible. Sneha says fine. Okay. So I'm starting. Please, JNV Dimitri students, check your audio. Okay. Avanti fellows is like it's closed there. Okay. But on the other side, I'm using different mic. I'm using different mic. Okay. Don't keep it off. From there, the voice is coming. Abhishek Sharma named mic is there. No. Don't switch off it from your side. Okay. I mean, it's not already switched off. It's on my hand. No. It's in my hand. Okay. See, okay, back to this thing. So we are having two these things like this. Maybe this is your technical issue. Okay, check it out. So this is a lens here. We'll understand what kind of lens is this. Okay. Now, if I'm combining two different spherical refracting surfaces like this, see here. If I'm combining two different refracting surfaces, yes, you can come. If I'm combining two different refracting surfaces, one is like this and other is like this. So how I can combine these two different looking refracting surfaces? कैसे combine कर सकते हैं? Either I can combine this like this, copy this and paste as it is. If I'm doing like this, I'll get a lens which is looking like this. So this you will understand, this is also among the types of lenses. Not now. Let us keep it like secret. Okay. If I am combining this like this interchange, if I'm placing this here in front of it and then combining, or if I'm placing this in front of it and then combining, so I'll get from this upper combination this kind of figure, like leaf or like rose petal. Okay. So, or lotus petal. So see, not lotus, like lotus is very big. So what I'll say here, this is also kind of lens. So till now we understood by combination of refracting surfaces in different manner, I get what? Different lens. Okay. One more we have seen in the previous, that is like crescent moon. Hai. This is for combining two different, so combining two same reflecting surfaces which are shaped like concave mirror, but they are not mirror because other side is not polished. ठीक है, other side is not polished here. ठीक है. Now students, since we have seen we have this, we can also combine a plane reflecting surface, okay, with these curved surfaces. So if you are doing this, we'll get one more figure kind of, suppose it's like this. Maybe it can be like this, or it can be, maybe you may find it will be somewhere like this. So these are the different combinations of reflecting surfaces. Okay, these are what? Different combinations. Different combinations of refracting surfaces. ठीक है. Got it, students? Yes. Now let us see the picture. Okay. So from here, what we can note it down? क्या note कर सकते हैं इसमें से? What are the things which we can note it down from this? We can note this thing first of all. Now you understood कि ये with the figures which are on your screen, how they came actually. We have combined two different refracting surfaces, or maybe two same refracting surfaces having the same radius of curvature. Okay. ठीक है. These are the combinations, several combinations. Maybe I have missed some combinations. ठीक. So first of all, write this definition of a lens in your notes. A lens is a transparent medium bounded by two reflecting surfaces such that at least one of the reflecting surfaces is curved or spherical. ठीक है. Then write in the next subtopic, like subheading, types of lenses. Then write here broadly the lenses are of the following types and draw all these figures. Since this is a convex looking, and different in radius of curvature, so I will say convex lens or biconvex lens. Yeah, Shushri, good afternoon. Good afternoon, Shushri. Please be focused here. Okay. So if I'm combining two convex looking surfaces, refracting surfaces, and they are having same radius of curvature, so I'll call them as equiconvex lens. If I'm combining a like a straight reflecting surface, here Dipti, me good afternoon. Okay, class has already started. You like, didn't you got this, or you're having some technical issues? Can you notify me? At least we can work on that. Students who are coming now, they were having technical issue or didn't got the message text. Didn't got the notification? What's the problem? Okay, no problem. Study. Okay, no issues. So this is what? Plane reflecting surface, and this is convex. So this will give you plane plus convex, matlab plane convex, plano convex lens. Similarly, concave convex lens. And rest of the names are, you can now yourself understand and match it. Convex plus concave, convexo concave lens. So I'll draw all these figures. I'm giving you 1-2 minutes for this. Okay. Yes, welcome all the students. Please note it down. We are on the lens. Note this definition plus this complete picture, and then we'll see. Okay, please note it down. I'm giving you 1 to 2 minutes. So after you have noted down, please text me in the chat box. Sir, we have noted down. Let us proceed next. Okay. Yes, you are right. If it is same, no issues. You no need to draw it. See, these two, no, diagrams are same. See, Sneha, you are making a mistake. See, it's good you texted. Diagrams are looking same. These two diagrams are looking same. But what's the difference? Isme the part of the reflecting surface, I mean the reflecting surface which they took here is having different radius of curvature, R1, R2. Isme both are having same radius of curvature. Similarly for this, isme they are having different radius of curvature. This is having same radius of curvature. Okay, got it? I hope it's clear. So please draw it again and then like draw it and then text in the chat box. If you have drawn, like we can go for the next slide. Okay, I'm proceeding. Okay, I'm going towards the next now. So this is principal axis. What does it mean, principal axis? Principal. And it means the axis passing through both of the center of curvatures of the two reflecting surfaces which are joined to make a thin lens. ठीक है? इसका ये है, इसका ये है. If you're considering this as the first reflecting surface, show the radius of curvature will be this side and this will be the center. If you're considering this as second reflecting surface, the radius of curvature starting from this will be in this side and this will be the center. Okay? So line joining the center of curvatures of the two bounding surfaces. Which kind of bounding surfaces? Refracting bounding surfaces. Is called what? Principal axis. Okay? Different. This is what. So corresponding to these centers, they will be having connected with this, linked with this radius curvatures also. Corresponding to this, it will be having radius R1 curvature, C2 ka R2 curvature. So I'll call them as what? These are convex. So I'll call them as different. No, I'll call them as biconvex lens. Biconvex lens. I'll call them as equiconvex. Sorry, biconvex. This is what? Biconcave lens. Or what was the name? Convexo lens or concave convexo lens or convex lens. If you see, there's a picture. See, convexo lens, and this is biconcave, or you can write simple biconcave, biconvex. Okay. Now, students, this is the formula. So that's the beauty of the topics of this geometrical optics. You know, let us make a flow chart. Before all the things, let us make a flow chart. Okay, just hold on. See, we started from where? We started from plane mirror. Mr. Plane mirror. We started from this. And I told you, this is a very good flow chart. Okay, you can paste it like, I mean, I'll give you the PDF. Suppose the object is present in front of the plane mirror at a distance perpendicular equals to D. So image will be forming inside at same D distance. This we know. And the formula for the image formation in case of plane mirror was what? That distance perpendicular of the object from plane mirror, okay, is equals to in magnitude distance perpendicular of image from mirror. Okay. Next, then we studied image formation due to spherical mirrors. Surfaces nahi, mirrors. spherical mirrors. Isme what we have seen, that if two mirrors are there, this is like this or maybe like this. So mirror formula, we know it is equals to this, where focus is r by 2. ठीक है, फिनिश, देख लिया था ना ये. ठीक. Now next thing, what we have studied after this, first we started from here, down, we started from this down, then we'll move this like this. These are the directions, you know, funny sound. Okay, so after this we have seen spherical surfaces. ठीक है, that is recently spherical curved surfaces for refraction. I think this was the third formula. If you are given a surfaces maybe like this and like this, so you know the image formation was somewhat like that, you know, different. So I've given the formula, what if it is having different refractive indices, n1 and 2. So we knew the formula was what now, it was n2 minus n1 upon radius of curvature. n2 matlab refractive index on the other side, and these are the boundaries. These spherical surfaces are acting as a boundaries separating two mediums, one having refractive index n1, other having refractive index n2. And remember, this refractive indexes n1 and n2 are the optical properties. Okay, so here n2 you will write as v minus n1 upon u. Okay, got it? Then let us move the flowchart more. Oh no, it's not a good line here. I mean, let's erase this one. Okay, so now proceed here and here, back. Okay, so if you see here properly, now we are seeing for the lenses. Abhi lenses ka dekh rahe hain. Now we are on the lenses. So if a lens is given maybe like this or whatever, but I'm taking a very simple case here. Remember, for a lens, the center point is known as O. It's known as optical center. This is just a flow chart. I'll explain you the big picture, okay? Optical center, and if the object is placed like this, okay, and if it is at distance u from the optical center, and suppose image of this object is I, and it is at v distance from the optical center on the other side, I'll say the formula of this is given by 1 by v minus, so you can match with the mirror formula, you know, for spherical mirrors. इसमें reflection, इसमें refraction हो रहा है, refraction 1 by f, where this focus is very big. I'll tell you. So this is a flow chart, okay? You'll start from here. So here I must put some boundary. So here I'm putting a boundary here. Okay. So this is see, first formula was very easy. Plane mirror, we have started from the plane mirror. First formula was very easy. Next formula, somewhat easy. I mean, you know, as compared to other formula. This one is big one, but this is the biggest. But you will say, sir, it's you know, small one. Just I put the minus sign in this. If you compare with the spherical mirrors, it's my plus hai. No, one more thing is changed. Here the focus was r by 2, but in this case, if you see, focus is very big. See, derivation you can see on the PDF, because here we'll apply 2 times that formula, that is a formula for the refraction from a spherical surface, n2 minus n1 r n2 by v minus n1 by u. This formula will apply 2 times, one for this surface, one for this surface. Okay, so through this combining, when we will combine both the formulas, see, first formula and the second formula, when we will combine these two formulas, we'll get this thing, and here we'll compare this to 1 by f, that is focus. So from here you can conclude in the mirror it was what, only r by 2, but here you will say, see, these are same points, same. I will, okay, we'll not come to back again this, that rays in this, for the lens the rays will be paraxial. Sign and conventions, r is the for first one, r2 is like for the second one. Lens should be thin. We are talking here for the thin lenses, okay. Thickness karenge to there will be many of the deviations of the rays due to reflection, and medium on both the side of the lens should be same, that you will see, okay. So this is the focus which you're able to see on your screen now. Go so dekho, see it properly. This is the focus. This is what? Lens. What kind of? If I'm considering this as, say, first part of the refracting surface connected with the second one, this will be R1, radius of curvature of the first refracting surface. This will be the second one, radius of curvature of the second refracting surfaces. So through this, I'll get the focus point as this. See, mu L is the refractive index of the lens. Mu S is the refractive index of the surrounding. Mu S here is again the refractive index of the surrounding. Okay? So through this, I'll get like this. 1 by F mu L upon mu S minus 1 upon R1, like this. Let me highlight this formula. So remember this. ये हमेशा याद रखना ये formula. Never forget this formula, okay? इस formula को भूलना नहीं है. Never forget this formula. This is lens formula. Okay, fine. Highlighted this, okay. So now let us solve 2 questions and then we'll end the class. I'll be solving it, okay. This I'll explain you someday other, next class. After this, prism is remaining, somewhat optical properties, and wave optics will be started. Ray optics, full course we have done in depth. You know, I mean, it's not like we've done all the topics. Practice numericals, this unlimited. You can do XII, Harish Chandra Goma, concept of physics, part 2. No, in the part 1, last chapters these are, okay, not part 2. Part 1 is available. If you see part 1, ray optics is the part 1, and you know, semiconductor electronics in the second part. You can solve it yourself. Okay? समझ में आ गया? You got it? So I'm solving this question. It's a very cool class illustration. Very good, Sneha. Okay. See, students, you have to work hard. There's no any other, you know, a shortcut path for this. You have to work hard. Otherwise, you can't crack it. Simple. No other way. If you say smart work, see, smartness is nothing. If you're understanding the things, you're working hard. You call it like you know, I'm understanding some smart. No. Just, you know, be very selective. Don't do only those questions which you already know. I mean, like you are becoming happy again and again. I'll solve this physics question from this book. Again, I'm solving the same types of no. So try different. Be very selective. So like if you're going for it with a particular strategy, this we can call as smartness. But you have to work hard. You have to spend the time. Okay. So see, in this question, it's given biconvex lens. And it's having bi matlab different radius of curvature. If it's given equiconvex lens, sure, it will be having the same radius of curvature. And it's given here refractive index of the glass is 1.5. Okay. So if I draw here lens, this is biconvex lens. First surface ka there 60 centimeters. So they are given here like this. This is the optical center. They have given R1, which is due to this, is 60 centimeters. They have given R2, which is due to this, as 15 centimeters. Refractive, oh. Okay, SB JNV have given the answer 40, excellent. Admin have given minus 40, excellent. Why? Because magnitude is right. I think the answer will be 40. Minus, we'll check it out. Okay, just wait, students. So all those students who have solved, very good students. You're doing good. Okay. अब इसमें क्या करना है? Simple students, we are given here refractive index of the glass is 1.5. Glass मतलब lens का refractive index, and they have told this thing that this lens is kept in the air. So if I call if I see the air ka refractive index is how much? It is mu surround, because see, I'm keeping a lens in the air means surrounding space completely ऊपर नीचे दाएं बाएं everywhere, upside down here and there, left right, everywhere it is one only. Here also it's one only. So when you apply the formula for the focus, you'll get this thing. क्या मिलेगा? What is the focus? What value are given? Mu L upon mu s minus 1 upon R1 minus 1 upon R2. ठीक है? Mu L is 1.5, mu s is 1 minus 1. R1, if you see, इसका curved nature is like this. So radius of curvature will be towards the center of this curved surface. If you see here, you're going in which direction? Let's suppose the object I'm keeping here, you're going in the direction of the object rays. So R1 here I will treat as positive. If you see R2, this is for R2. R2 is 15. I've written here already. Okay. So if you see this, R2 is like this curve. And if you go along this R2, you'll be going in this direction. If you go along this R2, you will be going in this direction. Okay. You will be going in this direction. Okay. So if you focus here, object rays are here and you're going in opposite. So it's negative. Simple. Or you can take convention, positive, negative. Optical center, origin, positive, negative. But all the things must synchronize. Okay. You're understanding? Both the laws, I mean, how we put the sign in convention, that was synchronized. Admin got 24 answer now. Okay, you had changed the answer, no issues. Now I'm putting the values here in front of you. See, R1 is positive 60, minus of 15. Solve karo. Sneha solved it. What's the answer? Subhalakshmi and all the students, JNV Dimitri students, you must answer. You see, yesterday you were performing so good, JNV Dimitri students. You did all the answers. You know, these like you and other people. One more student was there. You solved all the questions. Maybe you have texted some answers. I remember. Barsha also did. What happened now? So if I solve this question, Suryadipti 24. Okay, I think 24 is the answer. ठीक है? इसको solve करेंगे. This will give you 0.5. मतलब half. If you solve this will give you 0.5. मतलब half. This will give you how much? Solve करो ना इसको. Minus 3 by, no, it's plus, sorry, it's plus. It will give you plus 5 by 60. It means what? This. So focus will be, I'm writing the value, it will be 1 upon 12. From this we get 24 centimeter positive answer. Okay? Remember students, so conclusion क्या है? Conclusion अभी conclude नहीं करेंगे. Focus, but remember this thing, इसमें if we see, if we note something here, if I want to note down something, I will note down this thing here, that यहाँ पे focus is coming out to be positive and magnitude is 24 centimeter. But I haven't concluded what I want to conclude, I haven't concluded yet. Okay. Now let us see this question. This one. Okay. Similar. Apply the laws here. If you apply the laws here, what the laws will be? This is mu of lens. Mu of lens minus mu of, sorry, mu of lens upon S. They're asking the focal length. Minus 1. This is the formula for the focal length. No, 1 upon focal length, I mean. 1 upon R1 minus 1 upon R2. Mu of lens is what? 1.5. Mu of surrounding medium is what? 1. Mu of lens is what? 1.5. Mu of lens is 1.5. Okay. Mu of S is 1. Simple. Okay. See, radius of curvature of the first surface is given as 60 centimeters. Radius of curvature of other is 30 centimeters. It means I'm writing in the convention directly. You must know it. R1 is positive 60. R2 is, sorry, R1 is 30. Positive 30. It's positive 30. R2 is this side. So it is again positive. See, both the surfaces are curved like this. So if I say R1, it will be in this direction. If I say R2, this will be also, starting from this will be in this direction. So this is also positive now. Okay. Put the values. Admin got this. Okay, you all people are giving the answers. Very good. Excellent. So इसको करेंगे solve. This will be 3/2 minus 1. These are both positive. So 30 minus 1/60. ठीक है, ये कितना आएगा? What it will be? It will be 1/60. Finish. ठीक है, answer will be this. 1/2 into 1/60. Focus you will getting it here is positive 120 centimeters. Is it positive or negative? Anyone can text. Is the answer right? It's positive, yes. Who is telling 40? 40 answer थोड़ी आएगा. How can you get 40 in this? Focal length 40 कैसे आएगा? Students, you can see we have found the answer. It's 60 only. Sorry, 120 आएगा. Answer is 120. Focus is 120 here. Focal length they have asked from us. ठीक है? If you focus, see here the focus is positive. Image will be formed here in this direction. Okay. So the conclusion at the last is this. If you are getting somewhere focus to be you're asking why the focal length is positive. So you can solve it. No. देखो ये R1. Oh, hold on. R1 is, I'm taking R1 this. It's 30. R2 is 60 positive. See, इसमें positive क्यों है? Because radius of curvatures are in this direction only. If you put here values, see surfaces are curved like this. ये curved surface, radius of curvature will be in this direction. ये भी curved surface, radius of curvature will be इसका in this direction. And if you keep the object here, we are going in the raised direction. It is positive, no? If you see this lens, इसमें radius of curvature will be in this direction. Radius of curvature will be in this direction. This, if I'm treating R2, this is positive. This is what? This is, if I say this is, suppose this is R2's kata. This is R1. If I say this is negative. Got it? But ultimate conclusion is this. So wherever you find focus to be positive, the conclusion of the session is this. If you find focus to be positive, it means converging lens. If you find focus to be negative, in the next class, I will give you the question or I will give you the PDF. The lens will be diverging. Diverging matlab aisa lens. This is known as diverging lens. Okay, got it, students? So that was all about today's class. I hope admin you got the answer of your question. Okay, these are some points. Converging, diverging lenses are there. Focal length, positive means converging, negative means diverging. So these are symbols. I mean, you can change the lenses with this. This is for diverging. See, we use for resistor, big resistors, simple symbols. Capacitor के लिए simple symbol. Similarly for lenses, we'll use for converging like this. For diverging, we'll use like this. It will be given on the PDF. Okay, students. So that was all about today's class. You can leave the class now if you're having no doubts. Okay, or you can participate and go and then please. Okay, bye bye.